Okay, E10, I'm going to make another YouTube clip. This time it's about the work on Friday. Again, it's more work with trig identities. So what I'm going to do is I'm going to do some of these. You're going to see if you can get through all of them. There are some really difficult questions here, but we'll see how we go. So first off, I'm going to start with some of the things that you need to know. So let's get some of the things that you need to know. Now, if you don't use this acronym, it's okay. All stations to central, and that's theta, and that's 180 minus theta, the acute angle, and that's 180 plus theta, and that's 360 minus theta. And if we go around anti-clockwise, there's 90 to 180, there's 270, and then there's 360 all the way around here because we're going anti-clockwise with our unit circle. The other things I'm going to need with my trig identities are things like tan theta equals sine theta on cos theta. We also need to know that sine theta equals the cos of its complement. You probably need to know all your reciprocals, so sine theta equals, let's go sec theta equals 1 on cos, cosec theta is a reciprocal of sine, and cotangent equals 1 on tan. They'll probably come in helpful. And the other one is sine squared theta plus cos squared theta equals 1. And of course the reciprocal of those, if I divide by sine, I'll get 1 plus cot squared theta equals 1 on sine, that's cosec squared. And if I divide by sine, sorry, that's not right. Oh no, that was right. What am I talking about? Cosec squared theta. And if I divide by cos, the very first equation, if I divide this by cos, I'll get tan squared theta plus 1 is 1 on cos. Well, that's sec squared theta. So, they're pretty much all the things we're going to need to know. So let's have a go here. First question. Tan theta equals 7 on 24. So here's question 1. Tan theta equals 7 on 24. And theta is between 180 and 270 degrees. And immediately I look up here and go, well, that's here. That means tan's positive, but sine and cos will be negative. So I draw myself a little triangle. Okay. I put theta in here. Tan is opposite over adjacent, so that's 7 and that's 24. And this is square root of 7 squared plus 24 squared. Now, if you grab your calculator out, I'm pretty sure that's going to be a Pythagorean triad, but I'm going to do it anyway. So 7 squared plus 24 squared, 625, that sounds right. So if I square root my answer, I get 25. So that equals 25. So now I go, well, cos theta is adjacent over hypotenuse, which is 24 over 25. But because I'm told this I know that the cos ratio is negative. So it's negative 24 over 25. And sine theta equals 7, opposite over 25. But again, because it's in that area, I know that sine's negative at that point. So the two answers are negative. Okay. Jump to question 4. And I've got some simplify. Now again, I'm not going to do all of this. So I've got sine squared theta plus cos squared theta over tan squared theta. Well, sine squared plus cos squared is 1, so it's 1 over tan squared. But I can go a bit further, because I don't like having the reciprocals, and I know my reciprocal of tan is cotangent. So that's going to be cotangent, which I can write as cot, cotangent squared theta. And I'm just looking at the answers, so 4a, cot squared theta. So I'll just write that as cot squared theta. Okay, what else have we got there? I'm not going to do them all, but look, in the textbook that I'm using, someone circled E. So I'll do A, C, E. I'll just do this column down here. So I'll go straight to C now. So C, what's that? 2 cot alpha over 1 plus cot squared alpha. Well, I know that 1 plus cot is cosec. Yep. So I get 2 cot alpha over cosec squared alpha. Now I'm just going to write them separately. So 2 times cot alpha times 1 on cosec squared alpha. Well, I know that 1 on cosec is going to equal sine. So, and also I know that cot is a reciprocal of tan, and I know that tan is sine on cos, so reciprocal is cos alpha on sine alpha. So just think about that. I'm just going to write it in red over here. Tan alpha equals sine alpha on cos alpha. So therefore cot alpha is a reciprocal, so it's cos alpha on sine alpha. Now, the same with that cosec. So if cosec alpha equals the reciprocal of sine alpha, well then sine alpha equals the reciprocal of cosec alpha. So I can write that now as sine squared alpha. Now remember that sine squared alpha, well, I'm going to write it like this because this might make it easier. 2 cos alpha on sine alpha times sine alpha times sine alpha. And that means one of the sine alphas will cancel, which leaves me with 2, now I'm going to write sine first, 2 sine alpha cos alpha. I don't know why, I think that's more convention. And that's how they've written it in the back. Okay, let's have a go at, that was A. Let's go E. Because the person who had this book circled it, so they might have thought it was hard. Sine A plus on cos A plus cos A on sine A. So what have we got? We've got sine A on cos A plus cos A on sine A. Now, what do I want to do? I want to get a common denominator. So if this was 2 on 3 plus 4 on 7, I get a common denominator by multiplying this one by 7 and 7, and this one by 3 and 3. But I haven't got a 3 and 7, I've got a cos and a sine. But it's the same thing. I'm going to multiply this one, top and bottom, by sine. I'm going to multiply this one, top and bottom, by cosine. So here we go. I'm going to get sine A times sine A. I'm really writing this out for you. And cos A, and I'm just going to write the one denominator because it's the same denominator, which is cos A sine A. But I like to write sine A first. So sine A cos A. And I wouldn't have even written that line. I would have written, well, that's sine squared A plus cos squared A over sine A cos A. And sine squared plus cos squared is 1. So I get 1 over sine A cos A, which is the answer. Okay, so that's a bit of simplifying. I'll do G. I'll do G for you. You should go and have a crack at it yourself. Let's have a look at what it is. Cosec squared theta minus cot squared theta. So cosec squared theta minus cot squared theta. Well, up here, I've got cosec is 1 plus cot. So I'm going to write, well, 1 plus cot squared theta minus cot squared theta. Oh, the cots will go. That equals 1. So that one was pretty easy. Now, don't worry too much about 5, 6, 7 or 8. You can do them if you want. What I really want to do is get down to question 14, which is the proofs. So the proofs are hard. So I've got 1 minus tan squared, so I'll start 14. 1 minus tan squared tan x squared. Plus 1 plus tan x squared equals 2 sec squared x. 2 sec squared x. Now again, with these, what you're trying to do is make the more complicated side simpler. So I'm going to take the left-hand side and I'm going to simplify it. So again, if you remember from the previous exercise, I'm going to need to know this. When I have a plus b all squared, that gives me a squared plus 2ab plus b squared. And when I have a minus b all squared, it gives me a squared minus 2ab plus b squared. So I'm going to invoke both of those. So here I've got 1 minus, so that's going to be 1 squared minus 2 times 1 times tan x plus tan squared x. And then here I've got 1 squared, which is 1, plus 2 times 1 times tan x plus tan squared x. Well, I didn't really need the parentheses, so I'll get 1 minus 2 tan x plus tan squared x plus 1 plus 2 tan x plus tan squared x. And if I minus 2 tan x and plus 2 tan x, they cancel each other out. 1 plus 1 is 2. Tan x plus tan squared x plus tan squared x is 2 tan squared x. If I factorise out the 2, I get 1 plus tan squared x, which I know from my trig identities is sec squared x, which is the right-hand side. And I love writing the QED, quod est demonstratum. So that's question 14. Now, I'm not going to do all of this. I want you to have a crack. Let's have a go at a fractional one. So I'll go to 17. So sec theta plus tan theta. So 17 sec theta plus tan theta. What are we going to make it look like? 1 plus sine theta on cos theta equals 1 plus sine theta all over cos theta. Now again, I'm going to grab the left-hand side and make it look like the right-hand side. No, I'm going to take the right-hand side. It's really easy. It's really easy. So I'm going to take the right-hand side. And it equals 1 plus sine theta on cos theta. And I'm really lucky because this is a fraction. I can just split it. So it's 1 on cos theta plus sine theta on cos theta. Or 1 on cos theta is sec theta. And sine theta on cos theta is tan theta, which is the left-hand side, QED. Very easy. Let's have a go at 21. Cot, is there a minus in there? No, it's not. Cot theta cos theta. Okay. So here I go with 21. Cot theta cos theta on cot plus cos. Oh, I'm getting down near the other work. I'm going to finish this up. So here's 21. Cos theta, was it cos or cot? Cot times cos. Cot theta cos theta over cot plus cos. Cot plus cos. Cot theta plus cos theta. What's that equal? What do they want us to do with this? Cos theta on 1 plus sine theta. Cos theta on 1 plus sine theta. Cos theta on 1 plus sine theta. Now, I know some of you are going to be thinking, oh, that's easy. I'm just going to separate the denominators. But you can't. You can't separate the denominators. So what am I going to do here? Will I take the left-hand side and try and make it look like the right-hand side? It's hard because I'm going to be multiplying by reciprocals, or am I going to take the right-hand side and make it look like the left-hand side? I think I'll take the left-hand side and see what I can do with that. So the left-hand side equals, what have we got? Cot theta cos theta on cot theta plus cos theta. Now, whenever you get cot or tan, always write them in terms of sine cos. So I'm just dealing with the top now. So I've got cos theta on sine theta, because that's what cos equals. That's what, cot equals. And I'm timesing by cos theta. Now that's all the top part of the fraction. On the bottom, I'm going to write that as cos theta on sine theta plus cos theta. And what I'm going to do is I'm going to do something straight away here. I want to put that over sine theta by multiplying sine theta top and bottom. Okay, so what do I get here? I get cos squared theta, because remember that's over 1. So cos is cos squared theta on sine theta. And underneath, I get cos theta plus cos theta sine theta all over sine theta. Now what do I do when I've got two fractions divided by each other? I multiply by the reciprocal. So I get cos squared theta on sine theta times the reciprocal sine theta. Now watch what I do here. I'm going to factorise out the cos theta. So I get cos theta on 1 plus sine theta. I just factorised out that top line here. I just rewrote that as cos theta 1 plus sine theta. Just the top line. Now watch what happens. Bit of mathemagic. Sine theta cancels with the sine theta. One of the cos thetas cancels with the cos theta. And what am I left with? Well, on top, I've got cos theta. And on the bottom, I've got 1 plus sine theta. Pretty sure that's what I needed to prove. Cos theta on 1 plus sine theta equals the right-hand side QED. Now, these are really hard. If you can do a couple, that's brilliant. Don't stress if you're having a lot of trouble. Just work through them, see how you go. Good luck, and then have a great break.